Now, just as a recap, we talked about what? We've talked about mass. That's in kilograms. We've talked about time. That is in seconds. We've talked about position. That's going to be in meters. What else have we talked about? We've talked about distance. That's also in meters, which is utilized to describe position. We've also talked about displacement. Which is a vector, which is also described in terms of meters and direction. So, yes, we've talked about speed, which is just a magnitude. It is in terms of meters over a second. We've talked about velocity. This is a rate of change, as well as speed is a rate of change between displacement and time. Speed was between distance and time. So this is as well in meters over seconds, but it also includes direction. We've also talked about acceleration. And remember that all of these things are built upon one another, ratios. And so this was meters over seconds squared. I failed to mention that in the last one, but this is acceleration. Acceleration is just a ratio of velocity with respect to time. Okay? So the next thing that we're going to talk about will be force. And force, in many cases, we're talking about the net force. The net force acting on an object that possesses some mass m is just going to be the mass times, or the product of the mass and the acceleration. Okay? And now, and we'll write this a little bit different, but I want to go over the units for you real quick. The units are going to be kilograms times meters per second squared. These units are identical to newtons. Newtons will describe units of force. Mass describes, kilograms describes mass, and meters per second squared describes acceleration. All right? Write that a little bit better. Acceleration. Okay? So, let's write this in a more mathematical form. Mathematical form is the summation of forces acting on an object that possesses a mass m times the acceleration. So the net force is the product of the mass and the acceleration. Now notice, acceleration is a vector. Force is a vector. In this case, we typically apply a force to an object. Just as a picture, we can apply a force to an object. Let's call this our net force. When we apply a force to an object that possesses a mass m, this object is going to produce, or we're going to be able to produce an acceleration with that force. Now notice that the arrow describes the direction of the force, okay? This arrow describes the direction of the acceleration. Whenever you apply a force to an object to produce an acceleration, the acceleration will always be in the same direction as the force. Whichever way you apply that force to that object, the acceleration is going to be the same. Okay? Think about that. If we apply a force in this direction, okay, then our acceleration, we have a net force, then our acceleration will be in the same direction. Remember that. Okay? All right.